there and welcome to another computer science video from me, John. In this video what we're going to do is we're going to walk through the 2016 sample paper, and the plan is to go through most of these papers all the way up to the current year. So let's not waste any more time. Let's look at the first question of the paper, and this is about binary trees. So it says a binary tree can be constructed using the following rules. The first rule is the first item becomes the root node. Items earlier or at the same position in the alphabet follow the left pointer. Items later in the alphabet follow the right pointer. So 1A says draw a representation of a dynamic binary tree with pointers using the data. So it's worth 2 marks, and what we have to do here is construct the binary tree itself using the 3 rules given. So the first rule said that the first item becomes the root node, and that means Newport is my root node. Canterbury is before N of Newport, so that goes to the left. So I place that in the left child of Newport. Oswestry is after N in the alphabet, and therefore it goes to the right child of Newport. Warrington is after N and after O in the alphabet, so that goes to the right child of Oswestry. Rugby, well, that one is after N, after O, before W, so it goes to the left child of Warrington. Bath, that is before N and before C, so that goes to the left of Canterbury. And then finally, Derby. Derby is before N in the alphabet, but it is after C, so it goes to the right child of Canterbury. The trick in the exam is to write out the alphabet here. That's what I would probably do to make sure I'm being 100% correct and not making any silly mistakes. And that'll get you 2 marks. In part B, we need to show how the above tree could be represented using a 2-dimensional array. So remember, a 2-dimensional array is just a table with row and columns. So in the middle part of my table, the middle column, I'm going to have all the data. Newport, Canterbury, Oswestry, Warrington, Rugby, Bath and Derby. And each one of those is going to have a position. So starting at Newport, it's going to have the position of 0. Canterbury is going to be 1, followed by 2, 3, 4, 5, etc, etc. And then what I'm going to do, once they've got numbers, is I'm going to assign the left pointer to point to the left child of Newport, for example. So if Canterbury has a position of 1, all I need to then do is say Newport's left pointer points to position 1. And if any of my nodes in the tree don't have any children to its left or right pointer, then I indicate that using -1. And all I have to do is go through my binary tree and assign the numbers into my table. Nice and straightforward for 3 marks. And this is what my table looks like. Okay, part C says make the following amendments to the tree represented as a 2-dimensional array. So what we need to do is actually amend the table itself. And there is 2 parts to this question. The first part is you get 3 marks for inserting new key into the tree. You get 1 mark for deleting Warrington from the tree. So let's start with CI. To insert new key, first we have to work out where it's going to go. Now there's a problem. Newport and Newquay are very similar. They both start with N. The second letter is both E, and the third letter is both W. So then you look at the 4th letter, P and Q. Q comes after P in the alphabet, and that means Newquay moves to the right of Newport. And now we compare Newquay with Oswestry. N comes before O in the alphabet, and therefore we move left of Oswestry. So because there's no child there, we'll place Newquay in that position. Now we need to change our table to reflect that. So what I do is I add a new position on the end, which is position 7, and I insert Newquay into my table. Newquay will have no children because it's to the left of Oswestry. Therefore, I indicate that using -1 for the left pointer and -1 for the right pointer. And the last thing to do for my 3rd mark is to change Oswestry's left pointer to point to my new data of Newquay, which is 7. And so far, I've got 3 marks out of the 4. The last mark is to delete Warrington from the tree. So if I was to remove that from my tree, all I have to do is connect Oswestry to Rugby. And I can easily show that in my tree by changing Oswestry's right pointer to 4. And that simple change gets me a mark. In part D, we need to give one advantage and one disadvantage of using a binary tree to store data compared with a linked list. So we're looking at different data structures and comparing them together. It's only worth 2 marks, so you get 1 mark for your advantage and 1 mark for your disadvantage. So our first advantage is saying data access is usually faster because we can use different traversal methods. We know that we can do pre, post, in-order traversals in order to traverse our binary trees in different ways. A linked list can't do this. The problem with binary trees is that we have a memory overhead. We have 2 pointers, our left child and our right child, whereas a linked list only points to the next data item, and therefore the binary tree has more of a memory overhead. For the last question, giving examples, compare a balanced and unbalanced binary tree and evaluate their effectiveness to solve problems by comparing the maximum number of comparisons to locate an item for each of the trees. The best way I could see you doing this is by physically drawing a balanced binary tree and an unbalanced binary tree. That's going to communicate to the examiner that we understand the concept of balanced and unbalanced trees. And then from there, we'll look at the number of comparisons needed to prove the point. So the first step is to draw my balanced binary tree. That means my nodes are full and their left and right children are completed. I'm going to have 3 levels, starting with the root node, level 1 and level 2, or 1, 2 and 3, depending if you want to start at 0 or not. And you can see that the left of the tree is equal to the right of the tree. Therefore, this tree is balanced. My unbalanced binary tree is going to be heavily weighted on the right-hand side. Notice there's no left children from the root node. You could show your unbalanced binary tree in a number of different ways. You could have had 1 child on the left of the root node, for example, but it doesn't necessarily matter. We're just trying to prove that we can show what is balanced and what is unbalanced. Now, if I was searching for a node, for example, or trying to compare with these nodes, I'd have to go through all 3 levels as a maximum in my balanced tree. Whereas in an unbalanced tree, the number of comparisons is unknown. As this is all weighted on the right-hand side, for example, we have 4 tiers of comparisons to potentially do. So in our unbalanced binary trees, it's usually more unpredictable if we're comparing different items. Traversals tend to take longer as we're trying to compare using different traversal methods, such as pre, in or post order traversals. We're checking blank children, which is going to take us longer. And there we have the first question out the way. Take a quick break. We're going to move on to the second question in just a second. Question 2 says, in the programming industry, professional codes of conduct are used extensively and they set rules that should be followed by programmers. State 5 reasons why programmers are required to follow rules under a professional code of conduct. Each reason must relate to a specific rule. So 5 points, 5 marks. So we need to state our reason and assign that to a specific rule from a code of conduct. The first point I'm going to make is having a regard for public health, privacy, security, well-being and the environment. It's important that as a developer, as a programmer, we need to abide by all of these things and ensure that the things we do don't impact people's health, the privacy of others, the security of what we're creating, the well-being of others and those around us, and the impact on the environment. The second part is, what about a regard for the legitimate rights of people or organisations affected by our activities? So whatever we create and produce, people have rights and organisations have rights. So we need to make sure that we think about those during our development. The third point, whatever we're doing and programming and creating, we need to conduct activities without discrimination to others. The fourth point, programmers should promote equal access to the benefits of IT. So we include all sectors of society in the things we create. And that might be even through accessibility options, making things clearer for people, high contrast options and things like that. And the next point that I've actually seen, don't claim competency you don't possess. So you can't work for a company or claim a job on skills that you just don't have. Throughout your time working for a company, you are required to develop your CPD, which stands for Continued Professional Development. It's important that you keep topping up your skills to stay ahead of the industry. Number 7, have a knowledge of current legislation. Everything you create should be based around current legislation because we want to create software that is legal. Number 8, respect people's views and alternative viewpoints. In industry, you're going to disagree with people, but you need to respect what people are saying and offer constructive criticism. Number 9, avoid injuring others, their property, reputation, or employment by action or inaction to what you do. The main one from that for us is probably the reputational damage of not delivering a project. Number 10 says you can't take a bribe. And this is acting in someone's favour by a gift or of money or some sort of promotion potentially in order to benefit one other person or a specific party over another. So moving on to question 3. Below is a segment of code from a high-level language, and we've got a little section of code there. Give an example of a reserved word table used by the compiler and construct a user identifier table that could be used by a compiler to translate the segment of code above into a stream of hex tokens, and that will get you 4 marks. The second part of this question just asks you to use the tables that you've created to translate the following line of code into a stream of hex tokens. The first thing we need to think about is, what is a reserved word table? So remember, this is a part of the compilation process, and reserved words are words that are obviously reserved by the programming language. Our identifier table, when we use self-documenting identifiers, we create those things. So that's made by us. So in order to construct my table, a reserved word will have just the reserved word and the hex token. And the hex tokens are unique. You can be made up. As long as they are unique for the question, you will still get the marks. Our identifier table is exactly the same as the reserved word table, although we have one extra column. We need to identify the type of data being used for that identifier. So I draw my tables out, then I have to go through my code. Total, that is going to be created by me. The equal symbol is by the programming language. The plus is also by the programming language, and the semicolon. Then I've got the print. The word print is reserved by the language, and I have an open bracket and a closed bracket. Top exam tip for you here, make sure that those brackets are separate. In the identifier table, like I said before, total in the code, that is created by me. Num input will be created by me also, and count will also be created by me. All of those will probably have the integer data type, and all I need to do is assign a unique hex token. Once I've done that, in the second part of the question, I just need to assign those hex tokens in a stream. So total was 7A, equals is 2A, 7A is total, the plus is 2E, and the num input is 7B. And that gets you 1 mark. Nice and straightforward. Moving on to question 4, and we have some Boolean algebra to take care of. So 4a says clearly showing each step, simplify the following Boolean expression using De Morgan's law and Boolean identities, and that's worth 3 marks. Part B, clearly showing each step, simplify the Boolean expression for 5 marks. So let's jump straight into question 4a. So redrawing this, I've got not A and B or A. The first thing I've noticed I need to do here is De Morgan's law, which is an A2 skill. I break the bar, I change the sign from an and to an or. Then I use the commutative law to swap round not B or A. And then I do not A or A. That gives me 1. And then with that 1, I'll do 1 or not B. which gives me 1 because the OR rule states that as long as I've got a 1 on either side, I'll always have 1. And that simple breakdown gets me 3 marks. Question 4b is a little more tricky. And again, I'll start by writing out the question. And usually the first step is always the hardest part. I'm looking here and I could always expand all the brackets out, but I've spotted that B and bracketed A or B, I know that cancels down to B using the absorption law. So that gives me A or B, or A and bracketed not A or B. Now I'm looking at the second half of the question. I need to expand the brackets here and try and get rid of those. So A and not A, or A and B is my expanded brackets. And then I can say, well, A and not A, anything ANDed with the opposite of itself is going to return 0. So there's going to be a 0 in there. So that reduces down to 0. And then I'll write this out again because it's just good to write in the exam for the examiner. And it shows that the 0 has disappeared. I'm left with A or B, or A and B. And I'll use that commutative law again to swap B with A and B. And once I've done that, A or A and B cancels down to just A. Again, using absorption here, and I'm left with A or B. And I don't think I can cancel that down any further, so that is the end of this question, and that will get you 5 marks. Just look at the number of steps that we've been through to get 5 marks compared with 4A. And I can't stress enough how important it is to understand the identities and the laws of Boolean algebra in order to tackle these questions. Moving quickly on to question 5, this is all about algorithms and programming. So you've got a chunk of code, and what you need to do in question 5a is to explain why it's good programming practice to use constants, meaningful names for variables, and annotation in computer programs. That is for 3 marks. 3 distinct sections there, nice and easy, 1 mark for each. So firstly, constants. A constant is something that doesn't change while the program is live. So it's set once and used many times. An example of a constant is VAT, for example. It's set at 20% currently, and it never changes. Now, if we do want to change it, then what we do is we change it when the program is not running. And the benefit to that is that when we change it once, everything else does change. That holds the constant. For meaningful names, it makes it clear what the variable is holding. For example, total amount will obviously hold the total amount, and that aids the readability of your program in general. For annotation, it's good programming practice to use annotation because other programmers will find the code easier to follow. For question 5b, from the above algorithm, identify a value and reference parameter. It's important first that we know what a parameter is. Parameters are usually passed between parentheses on a procedure or a function. They're usually in the top. So at the top of this algorithm here, we've got declare subprocedure find area r, a. Those are our parameters. Then we need to look at a value parameter. A value parameter means that we can't change the value. And then we've got a reference parameter which passes in the original address, which means we can change the value in its original location. So in this algorithm here, we've got A and R being used in our algorithm. The line that says set A to equal pi multiplied by R, which one is a value and which one is a reference? Well, the value one is R because it's being used and it's not being changed. A is the reference parameter because it is being assigned using the equal sign pi r squared. So A has to change and R is only used. That makes R our value parameter and A our reference parameter. For question 5c, we need to explain the difference between a value and a reference parameter, giving an advantage of using a value parameter. So again, 3 marks, 3 distinct parts to this question. A value parameter is when a copy of the data is passed into the procedure and cannot be altered. The key here is to remember copy, and that stops the data being changed by mistake, and that's our advantage. Reference parameters, a copy of the memory address is passed into the procedure and therefore it can be altered in its original location. Now let's have a look at question 6. Explain the facilities available in a typical IDE or integrated development environment that would assist when debugging a computer program. So 4 marks here, and there's plenty on offer for this question. A debugger is a software tool used to detect, locate and correct faults in a program and will permit an individual to do any of the following. Firstly, to step through or inspect programs at runtime, to add a breakpoint in and halt at a fixed point in the code, to use variable watches to view a value of a variable at a specific point, or to view the entire contents of memory at a specific point while running the program. And you can do this using a store dump. Or you can also use an IDE to view error messages using the built-in error diagnostic tools of the IDE. Any of those 4 points will get you 4 marks. And that list is not exhaustive, so you could add any more there that I've not discussed and you'd still get full credit. Now we'll look at question 7, which is a backers no question. The email address of staff at a national bank are made up of a first name followed by a full stop, followed by a surname, followed by a single digit, followed by the @ sign, followed by nb.co.uk. There are our rules for our language. All the first names and surnames consist of a lowercase character only and can be of any length. I'm reading there that it must be a minimum of 1 character or multiple of that. 7a says, produce appropriate syntax diagrams. That implies to me there's plural here to define an email address at National Bank. So remember the shapes for our diagram. Anything inside a circle is a terminal, and my lines represent OR. So in my lowercase rule, it looks like this. I can have an A, or a B, or a C, or a D up to the value of Z, and I can carry on and choose one of those. My digit is very similar, but the terminals are replaced for digits instead of letters, and that is what I need for my setup. In my email address rule, I'll have a lowercase non-terminal, followed by a terminal of a full stop, followed by a lowercase non-terminal, followed by a single digit, followed by @nb.co.uk. And don't forget, the lower cases here need to be recursive, so I draw my line, reconnecting me back to the start, and both of them do that. Because it did say, all first names and surnames consist of a lowercase letter only and can be of any length. So you must choose one, but you can have as many as you want. In 7b, we need to produce an appropriate backers no form definition for an email address at National Bank. So basically it's converting my diagram into its correct backers no syntax. Non-terminals start with chevrons, and I put my non-terminal rule name inside there, followed by 2 colons and an equal symbol. My terminals are separated by pipes or a straight line up to the value of Z, and that is how I declare my letter rule. The digit is then declared, and then I need to think about the recursive names of the first name and the surname. So I make a rule called name, and I assign to name some letters. So you must have a letter, or you can have a letter and then the name of the actual non-terminal again. And that means you'll call the rule again. And that's recursion there, which means we can choose as many letters as we want until we choose one letter and stop. So now I've got all of the ingredients for my final rule. All I need to do is declare it and add it all together. I make a non-terminal rule called email, followed by 2 colons and an equal symbol to assign the name non-terminal, which is recursive, followed by a full stop, followed by the recursive name again for my surname, followed by a single digit, and then @nb.co.uk as terminals. And that will get us 4 marks, 4 lines for question 7b. In part C, we have to explain why programmers find both syntax diagrams and backers no form notation preferable methods to describing the syntax of programming languages compared with natural English. Natural English is what I'm speaking right now. So the syntax of computer languages, they follow strict, unambiguous rules. That means they can't be interpreted in more than one way. But the English language can be ambiguous. Syntax diagrams give a diagrammatic representation which is easy to follow, especially for novice users, because often a picture is worth 1,000 words. And finally, due to the unambiguous nature of Backer's no form, definitions can be easily coded when you're writing a compiler. And there's 3 points for our 3 marks. For question number 8, we've got a maximum of 6 marks on offer. A software development company has produced a stock control system for a small retailer. Using examples, describe different types of maintenance that should be carried out on the stock control system. So as soon as they say maintenance, I'm thinking adaptive, perfective and corrective maintenance. 3 different types of maintenance, 6 marks on offer. 2 marks per maintenance type. So what about perfective maintenance then? Well, in perfective maintenance, system functionality is improved. For example, in this situation, it could be for reducing the search time for stock control records, for example. When we apply adaptive maintenance, this is when the system is changed to run on a new hardware or software platform. It could be changing from the retail company moving from Windows-based system to a Macintosh or a Linux-based system. That would need adaptive maintenance. And finally, corrective maintenance. This is all about fixing bugs in the system that were not detected during the developmental or the system testing stage. So for example, users might find that some data input for new stock is not validated and this causes the program to crash or produce an inaccurate result or output. And in order to fix this, we need to come in and apply corrective maintenance to a working system. And there we have it. Each type of maintenance has been explained and then I've provided an example in order to get my 2 marks per maintenance type. In question 9, below is a section of a program that makes use of a recursive algorithm. And then below we have our recursive algorithm that says declare subprocedure recursion algorithm n num. Question A says identify the main features of a recursive algorithm. So the code isn't really needed here, it's for 2 marks. And we're all happy with a recursive algorithm. It's one that calls itself within itself until a base case or a terminating condition is met. So 2 marks, 1 for saying what a recursive algorithm is, saying it calls itself within itself, and then you get the 2nd mark for explaining that there's a terminating condition or a base case. In number 9b, it states describe giving reasons to problems that a programmer might encounter when using a recursive algorithm. Well, firstly, a recursive algorithm does lots of calls to itself, so that potentially could make us run out of memory. Every time we make a call, it gets put on the stack. And due to a high number of recursive calls, we can end up running out of memory and overflowing our stack. And that would get you 2 marks. You could also say it's difficult to debug or dry run if your system is producing incorrect results. And that's down to the difficulty in determining which recursive call actually produced the error. And again, that would get you 2 marks. Now we jump over to question 10 and we're looking at program paradigms, more specifically the object-oriented programming paradigm. So it says explain the terms class and inheritance in object-oriented programming. So we've got 3 marks in total for this one. So I do like to draw the diagram to explain the points here. A class is a template or a blueprint and it defines the methods and the attributes used to make objects. Our methods are our doing and our attributes are what makes up our system, like our variables. Inheritance is when a new class is created that is based on another class and it can take on the methods and the attributes of its parent or base class. So where do we actually get our marks for this question? Well, the first mark comes from saying a class is a template defining methods and attributes used to make objects. The second mark comes from talking about inheritance of when a new class is created that is based on another class. And the final mark comes from saying that when we create this new class based on another class, it can take on the methods and attributes of its parent class. So 3 marks in total for this question. Okay, on to question 11. So we have to write an algorithm in pseudocode here that will input 10 integers into an array. Search the array of 10 integers for the largest value and output the largest value. Here we can use something like a linear search in order to search for that largest value. So all I'm going to do in my pseudocode is declare an array. I know it's exactly 10 integers, so I can put my array 9 is integer. That declares a single array with 10 integers inside it. And they're all blank at the minute. Then I can do a for loop because I know specifically how big my array is. I can loop exactly to that size. So I'll say for I equals 0 to 9. And then I will start by saying my array at the position of I is assigned the input number. So I will loop through the whole of my array, each element, and input a number. Then inside that loop, I'll say if my array at the position of I is greater than max. Max is declared as a variable to hold the maximum value. If the element in my array is greater than my current maximum value, then I set max to equal whatever that value is from my array. And then I move on to inputting the next number. So that will keep the maximum value in that variable. And then all I need to do once I've finished inputting all the numbers is output the maximum value. The 3 marks for this question come from successfully adding 10 inputs into the array, correct control structure of repetition using a loop, and identifying using selection and outputting the largest value. And that gets you 3 marks for this question. Looking now at the second part, we need to input 10 integers into the array again and then sort the array of 10 integers into ascending order. Output the 10 integers in ascending order. Now this is worth 6 marks, so I've decided here that I'm probably going to use something like a bubble sort in order to sort the list in ascending order. So for this bubble sort, I will start my procedure and call it sort my array. I'm going to set n is integer because that's going to hold the number of elements in my list. I set temp as integer because what I'm going to do is I'm going to use that in the swapping process. I need a Boolean flag to ensure that I've swapped a number or not. If I swap a number, I know that my list is not sorted. So then I'll say set n to equal the length of my array. And I know in this it's going to be 10, but that can be for any size list. Then I've got my first iteration, my repeat. I'm going to repeat until my swapped value is false. And if that's false, then that means I haven't made a swap and my array is sorted. Now I need to make sure that I initialize the swapped value to equal false inside my repeat. And that's to ensure that it's set to false. In case I don't do any swaps, it should break out the loop. Then we get started with the swapping itself. The outer loop in a bubble sort is used for passes. The inner loop is used to control the swaps. So for I equals 0 to n minus 1, so for 1 less than my list length, if the thing I'm looking at in my array is greater than the consecutive number next to it, then we make a swap. So that greater than symbol ensures that my list is in ascending order. The temp value is then given, the value at my array I plus 1, and then my array at I plus 1 is overwritten with my array at I. My array at I is then given temp. And what you'll see there is the numbers actually duplicate and then they swap over. Without the temp variable, we would overwrite the number and we'd lose it forever. All that's left to do now is end my if. Next I continues the loop through each number and end my repeat until loop, setting the swapped condition to equal false, and then I end the procedure. And that's my bubble sort for 6 marks. Now, to get 6 marks in this, you need to show the correct control structures. So the nested loop gets you 2 marks, comparing values for the ascending sort gets you 1 mark, successful swapping of elements gets you 1 mark, and the algorithm that terminates correctly gets you a mark as well. And then finally, the algorithm that deals with identical values gets you another mark. And in hindsight, I probably should have put greater than or equal to in my algorithm. Interesting, no marks for the outputting of the integers, which is quite strange, but there we go. Moving on to question 12 then. And yes, it's a big O question. Below is an algorithm that calculates the product of 2 square matrices A and B. Both matrices have dimensions n by n, where n is the number of rows and columns in each matrix. So my algorithm is below that, and I've got 3 for loops with some code inside the K loop. Question 12a says determine how many multiplication calculations are carried out when n is equal to 10. Interesting. So I look at my I loop and how many calculations would be carried out there if n was set to 10. Well, it would be 1 to 10 in my I loop. For j, it'd be 1 to 10 also, and k, it'd be 1 to 10. So how many multiplications are carried out? So I can only see one multiplication inside the k loop. So if it's inside the k loop, for every one run you do I, you do one run of j, and for every one run of j, you do one run of k. So in actual fact, it's 10 every time, but they're nested inside each other, so it'll run 10 cubed, which is 1,000. And that means if I change it to 100, that will be 100 cubed, which is 1,000,000. And that gets you 1 mark for simply identifying that iteration. So the next part of this question says evaluate the efficiency of the algorithm and using big O notation determine the growth rate for time performance. Your answer should refer to the addition and the multiplication calculations performed by this algorithm. So that will get you 5 marks. Now, time performance is very different to the memory space used by the algorithm. So bear that in mind as we do this question. Okay, the first step is to identify the addition and the multiplication carried out by the algorithm. So inside the K loop, I've got a multiplication in there and I've got a plus in there. I also have another plus when it says next K, because next K actually means K equals K plus 1, and that is an incrementation of K. So in actual fact, I've got 1 multiplication and 2 additions inside the K loop. And we worked out before that anything that happens inside the K loop is n cubed. So I've got 1 n cubed and 2 n cubed additions. The other additions I have inside the J loop is j equals j plus 1, and that in the J loop it's nested, which gives me n squared. So I have 1 addition inside the J loop, which is n squared, and finally I have another addition in the I loop, which is 1n. So a tip here is that every time you nest an iteration, it goes up by a power. And if you add all them together, you'll get 3n cubed plus n squared from the J loop plus n from the I loop. And as you scale this up with data, n becomes insignificant, n squared isn't as powerful as n cubed, and for the 3n cubed, 3 is a constant which you drop anyway. So the 3n cubed, or the n cubed on its own, is more dominant than all of the terms. Therefore, this algorithm for its time performance is order of n cubed. And finally, part C. Using big O notation, determine the growth rate of memory space used by the algorithm. So the question stated that we know we're dealing with matrices that have dimensions n by n. So if you look inside the K loop, I'm actually setting answer ij to equal answer ij plus aik multiplied by bkj. So what I'm storing inside answer ij is the result of answer ij plus the multiplication of matrices A and matrices B. I'm dealing with 3 matrices in total, A, B and answer. And like I said before, each matrices is n by n. So I've got n by n is n squared, and I've got 3 of those. And if you apply the same rules that we did before with constants, we drop the constant, n squared over time, if you scale it up, becomes more dominant, and therefore, for the memory space used, this algorithm is order of n squared. And that gets us our 2 marks. Finally then, moving on to the final question. And I appreciate it's been a long video, but stick with me on this one because this is usually where students need to bank as many marks as possible to make the difference between those grades. And this is question 13. A software company encourages their programming teams to write using modules. Discuss Implications of writing programs in modules. You should draw on your knowledge, skills and understanding from a number of areas across your computer science course when answering the question. And it's 12 marks in total. So the key bits for me here is 1, I need to be talking about programming teams, 2, the fact that we're doing it in modules, and the implications of writing in modules itself. And then we've got our bottom bit there, which is always generic on the last question. So the first thing, I'm going to talk about the algorithms and programs chapter. So I'm going to talk about the fact that we use in constants. So the use of constants, they allow modules to be easily updated. For example, when the VAT rate, for example, changes a module that creates the gross price, it can be updated by only changing the constant value for the rate of VAT. And that means everything else changes. We can use standard functions. And that means that they'll apply to multiple modules when we're writing functions. You can use meaningful identifiers across all the modules so that every person or every developer working on the system actually knows what convention that they're going to write in. You can use local variables to ensure that the system is highly cohesive and loosely coupled. And high cohesion means keeping parts of the code base that are related to each other in a single place. Low coupling is at the same time, it's about spreading unrelated parts of the code base as much as possible. And that's why we use local and global variables in a meaningful way. And if possible, global variables should be avoided at all costs. We can also use parameters during modularity to pass data across different procedures and functions, and all variables and parameters should be documented. Modules can be tested individually before integration, and this means that the people working on the modules can also test them. And finally, we have the benefit of data independence, and this means that underlying data structures can be altered without affecting existing modules, so everything is kind of standalone. Moving on to a different chapter of our specification, what about the principles of programming chapter? Different paradigms or different languages facilitate modular programming, such as the object-oriented language. It could be considered as a module each class, and it supports a bottom-up approach and a structured top-down approach. And the benefit to writing in modules is that you can agree on standards of integration, different platforms, and different types of maintenance. The next chapter that we'll look at in computer science is the system analysis chapter. Think about the different types of approaches for modular programming, such as the waterfall or the agile approach. They are suitable for both of those things, and you can integrate one module at a time, and you can stick to milestones for the waterfall approach, or you can stick to development cycles and feedback for the agile approach, because everything's independent. And then what about the fact that you can improve a module and then swap it in and swap it out, and that's improved in the functionality in the agile approach, for example. So modules can be reused as many times as you like. There'll be repeated code in there that you can use, and also they can be tried and tested, and there's less chance of integrating future errors in there. One of the major advantages of using or writing modules is the fact that teams can be deployed on certain modules wherever their strengths lie. Thinking of another chapter on that point, what about software engineering? Well, if your teams are using things like integrated development environments, what about developing in modules that it's easier to debug smaller, more manageable chunks of code? What about the fact IDEs can be used to create a library of modules? Again, that's enforcing the reusability of them. In your IDE, program version management can be used on your modules to ensure that the latest version is being used, updated and developed. Moving on to program construction, another chapter. What about the fact that there's no need to recompile modules? I'm not saying that no modules need to be compiled. What I'm saying here is, well, some modules are set and finished where you can keep them and they don't need to be recompiled again, but newer modules, they may need to be. So you're actually going to save time during the compilation process by not recompiling everything over and over again. And finally, modules need to be relocatable in RAM. So our most frequently used modules are usually placed in RAM or cache memory because we need faster access to them. However, some modules may take a little bit longer because they need to be relocated and brought into RAM. So that is a trade-off between performance and relocatability. So there you have it, So in order to get 12 marks for that question, these last questions are banded. So band 3 is obviously the top band that we're aiming for. It's between 9 and 12 marks. So you need to make sure that you've written an extended response that has a sustained line of reasoning. Okay. Now you need to limit the amount of repetition that you've done and show clear understanding of what the question's asking you across the whole computer science specification. Okay, so you need to also have presented a balanced discussion and justified your answer with examples where possible, and effectively drawn together different areas of knowledge and skills, like I said, across the course that you've been studying so far. Technical vocabulary and terminology used confidently and accurately will always improve your banding on these questions, okay? So you need to make sure that you're answering them with technical vocab. And finally, there's nothing really much for me to say now. You asked for this video. I know it's very long. Hopefully you find it some use. I will timestamp it and put it below in the description. So I've been John. Thank you very much, and I'll see you again.